Ethernet is rapidly becoming the network of choice for higher-level industrial applications, such as connecting PLCs, instrumentation, devices, and controls. This video will explore the differences between the categories of Ethernet and how cables are constructed to meet the requirements of these categories. The categories of Ethernet refer to the speed and frequency of the data exchange. As you can see, as the cable category increases, so do the transmission speed and frequency. The difference between the two Cat6a categories is the Class EA version provides a reduction in near-end crosstalk noise. If you consider the attributes of a cable in terms of a highway, it becomes easier to visualize the differences. Let's assume transmission speed equals speed limit on a highway and frequency equals the number of lanes. A higher frequency range increases the bandwidth, which adds more lanes. In basic terms, higher category cables can move more data at faster speeds. One of the most important factors to consider when retrofitting or designing an Ethernet installation is that the speed of the entire network reverts to the lowest common denominator. So, using Cat6a cable with Cat5e components will result in a Cat5e system. Meaning, in order to achieve the speed of the category, every component of the system must be capable of achieving the speed of that category. From a cable perspective, different construction methods are needed to meet the speed requirements of each category, and it's all about the twists. Ethernet cabling consists of either 2 or 4 twisted pairs. Each cable construction is designed with specific twists per inch for each individual pair. Each pair needs to be different from other pairs in the cable to prevent crosstalk, especially between unshielded twisted pairs. This will vary by conductor OD, number of conductors, 2 or 4 pair, shielded or unshielded pairs, stranded or solid conductors, and also differs between manufacturers.